All right, so picking back up where we left off last time, talking about reference angles. Reference angles, remember, are the angle that is an acute angle, and it's created by taking the terminal side and going back to the nearest x-axis. And we did one example over here, number 4, where we were in quadrant number 4, and we paused because number 5 has radians. We knew it would take us a little bit longer to think about, and because number 5 has a negative angle, which is also a little different. Let me do that. Let's try again. There we go. So first of all, negative means I'm going to do what? What happens when I have a negative angle?
It's going to go clockwise.
We're going to go clockwise, and we always start where the standard position is, which is the positive x-axis, and we go clockwise. So we're going to move this direction, and we're going to move around clockwise from here. So we're going this way. How far will we go? What quadrant will we end up in if we go negative 7 pi over 6? We will end in the second quadrant. Now, if you're not comfortable with radians, that's still okay, because what you should recognize here is that this is also a fraction. So hopefully you're a little bit more comfortable with fractions than with radians, even if you're not liking radians. 7 over 6 is a little bit more than 1. And if I went around 1 pi, I would be right here at the negative x-axis. So I need to go a little bit more than 1, which will put me into quadrant 2. All right? So if I take this angle, negative 7 pi over 6, is this whole angle right here. But what part of it is the reference angle? Yeah, just this little part right here, right? And it doesn't matter to me which direction you draw your arrow or whatever on this description, because your reference angle is always a positive value anyway. So if I had gone around from where I am all the way to here, I'm at 7 pi over 6. But if I had gone all the way from here just to the negative x-axis, I would have been at negative pi. So how far, what's the difference, in other words, of the little pink portion that I've drawn in? It's 1/6 pi. Right? Yeah. Because this right here is the number 1 from here to here. This piece all the way around here is the number 1 and 1/6. That's what 7 is. 7 pi over 6 would be 1 and 1/6 pi. So this pink portion right here is simply pi over 6. And again, the whole point in the reference angle is that it's a positive value. It's an acute angle. Okay? So we got that actually by taking 7 pi over 6. And basically, we're subtracting off pi. Remember what we did over here is we took 360 degrees and we subtracted off the 330. So there is no formula, per se, for finding reference angles. It's based on what quadrant you're in, whether it's a positive angle or a negative angle, whether you're working in radians or degrees. There's so many variables that if I want to give you a formula, I'm going to have to give you like at least 4 formulas for the 4 different quadrants. And they're going to look different with degrees or radians, so let's just make that 8 formulas. That's ridiculous. There's no need for a formula. The picture tells you what to do. Okay? So that's reference angles. And we need the reference angles to be able to work with our trig functions when we have an angle that we don't have a standard form for. All right, so if you take a look at this 14 pi over 3, you can do this one of 2 ways. If you want to deal with the 14 pi over 3 as 14 pi over 3, we can deal with it in radians. If you really hate radians and you want to change it to degrees, you can do that too. All right, either is optional, or either way will work. Either option will work, let's say it that way. So one of the things is I'm going to deal with it in radians because I know that most of you are not comfortable with radians and you need to become more comfortable with radians. So we're going to deal with it in radians on the board. If you really hate them and you want to work in degrees later on your work, that's fine. So 14 pi over 3, I don't know exactly where that is, but I know that 14/3 is bigger than 2, right? And why am I using the number 2? Well, because 2 pi would be going all the way around the circle one time. So just like when you're working with degrees, if you've got a number bigger than 360, you can automatically subtract 360 away, right? Because that's a full rotation of the circle. If you're working in radians, you can automatically subtract 2 pi away. So let's take our 14/3. And again, it's 14/3 pi. But I want to subtract 2 pi. Now, 2 pi and 14/3, in order to subtract 14/3 and 2, what do you need? Common denominator. So instead I could write this as 14 pi over 3 or 14/3 pi. And I would subtract what? 6/3 pi or 6 pi over 3, right? Because 6/3 is the same as the number 2. So if I take 14 and I subtract 6, what do I get? 8. But 8 pi over 3 is still bigger than the number 2 pi over 3, still bigger than the number 2 pi, right? It's still bigger than 2 pi. And I know that because I already figured out what 2 pi was. It was 6 pi over 3. So I can take that 8 pi again, and I can take off another 2 pi. So what happens if I take 8 pi over 3 minus another 2 pi, or 6 pi over 3? 2 pi over 3, or 2/3 pi, depending on your perspective. And that actually at least tells me where I am in terms of one rotation of a circle, right? It still may not be the reference angle. I still may not want to use it in that direction, but it at least gives me a place to draw my angle from. So I need to figure out where 2 pi over 3 is. So where is 2 pi over 3? Quadrant 1? Quadrant 2? I've heard both. 180 is pi. So if I went all the way around the circle to pi, or half the circle to pi, I'd end up over here, right? So it'll be in quadrant 2. I need to go 2/3 of the way. Agreed? 2/3 of the way is more than half, so I am going to be in quadrant 2. So 2 pi over 3 is going to be this piece over here. Where's my reference angle? Right here, right? That piece is actually my reference angle. All right, so I can actually consider what happens at pi over 3 and look at that. Now, that's almost right, so let me find what tangent of pi over 3 is, and then we'll talk about what's happening because we're in quadrant 2, because we are in quadrant 2, which changes things a little bit. All right, so tangent of pi over 3. Pi over 3, if I created a triangle that had a pi over 3 angle in it, oops, let me draw the triangle correctly. There we go. So here's pi over 3. Pi over 3, Caitlin wants to tell me what the angle measure is in degrees, don't you? That's a 60-degree angle, so if it helps you think about that in 60 degrees until we get to section 5, 60 degrees, okay? Well, that's one of our special angles, isn't it? 30, 60, 90, and 45. So I actually have a measurement of a 30, 60, 90, or I can think about the triangle in terms of 30, 60, 90, and the way those triangles work is I've got a 1 here, I've got a square root 3 here, and I've got a 2 here on the sides of a triangle. And this is asking me for tangent, and so what is tangent here? This would be square root 3 over 1. Now there's one other issue that I haven't dealt with. I haven't dealt with the fact that I'm in quadrant 2, and you can deal with that in one of two ways. You can either remember that in quadrant 2 the tangent value is negative, right? It's negative in quadrant 2, so you can remember that, right? We talked about the ASTC last time. So tangent is positive in quadrants 1 and 3 only. So you can remember that. That's one way. Or you can do it from the picture. So take a look at the sides of my triangle where I put them. One of them is negative. Which one? The square root 3 or the 1? The 1. This 1 value is actually negative because I'm actually on the negative x-axis, aren't I? So if I think about it from the triangle perspective and the quadrant, I still have to take into consideration what quadrant I'm in order to make that work. I've got a negative. So if I took the square root of 3 and I took the 1 and I do the ratio for tangent, I still get a negative square root of 3, right? So this is actually negative tangent of pi thirds. But I used the pi thirds to create my triangle. So it doesn't actually equal the same value as the tangent, but with a plus or a minus it does, right? It's either positive or negative, that value. All right, let's take a look at one more. Find the exact value of each of the remaining trig functions of theta. We are told that sine of theta is negative 2/3, and we're told that we are between 180 degrees and 270 degrees, which tells me information about my quadrant, right? It does. What quadrant does it tell me that I'm in?
Quadrant 3.
It does. So I'm going to draw my picture to represent that. That's not a very good one. If I'm in quadrant 3 and I create my triangle, this is my picture, correct? I've got sine of negative 2/3. Okay? So sine is what in a triangle? Opposite over hypotenuse. So the opposite side of this triangle is going to be the horizontal one that doesn't look very horizontal in my picture, but that's the negative 2. And then the hypotenuse is the terminal side of my angle, which is 3 right here. Because this is representing a value going down.
But a distance can never be negative.
I agree, but this point right here, it has the y value that is -2. Okay? So this distance being negative gives me a sign value that's -2/3. It's not just talking about the length, it's talking about the location of your triangle, or your angle, depending on your perspective. All right. But I need the third side, or at least that's one way of doing this if I'm going to find the other trig angles, right? Or trig values. And you guys know how to do that. You've known how to do that before you encountered this classroom, I could tell. How do you do that?
A squared plus B squared equals C squared.
Yep, and so that's going to be the -2 squared plus b squared, because I called it b, equals 3 squared. So -2 would be 4 then. 4 plus b squared equals 9. So what is b squared? 5. Now, well, b squared is 5. What is b? Is it square root of 5? It's negative square root of 5. Why is it negative? Because I'm on the negative side of the x-axis, right? This distance, just like Alexander said, the distance is not really negative. I get that, right? But the x value itself that I'm going that distance of is in the negative part of the x-axis. So that's why the negative's there. So this actually is negative, right? So I've got negative square root of 5 here. All right, so I didn't need to do that actually to find one of them. What trig function could I have done without the triangle? Cosecant. Cosecant. What is cosecant? Yeah, it's the reciprocal of sine, so it's -3/2. Put the negative on top, the bottom, and the front, it doesn't matter. But the triangle gives me the rest of the information that I was looking for. So let's do tangent next. I don't know why I chose tangent. Usually I would do cosine, but let's do tangent. What's tangent going to give me? So here's my angle theta. It should be opposite over adjacent, right? Okay, so some of you are already simplifying, but I know that not everybody is able to think that way yet. So I'm going to write it exactly like it would be first for simplifying. It would be -2 over negative radical 5. Does everybody see where this came from? The two negatives are going to cancel, which is good because I'm supposed to get a positive tangent value in quadrant 3, right? And then I need to rationalize by multiplying by, radical 5 over radical 5. So if I do all of that, I end up getting 2 square roots of 5 over 5.
Why isn't 3 negative?
The radius is always measuring a distance. It's the conventions that we use to get the trig functions to be what they properly are. The triangles work for us. So. How would you know whether it's positive or negative anyway? Because it's actually not representing an x value or a y value, whereas the sides of my triangle are. All right, so here's tangent. Cotangent comes from that as well. So what will cotangent be? Yeah, and in fact, I don't really even want to look at this value for tangent, right? That's not so helpful. It'd be more helpful for me to look at the one before I rationalized and then flip that one. And I can ignore the negatives, or the negatives cancel out. So I actually have radical 5 over 2. Cosine. What's cosine going to be? Negative square root of 5 over 3. Good, because it's adjacent over hypotenuse. I don't have to do any manipulating with that one. I've got one left, secant. So what will secant be before I simplify? Negative 3 over square root 5. Okay, I can't write that low on the screen apparently. Let's try again. Okay, pretend like that says square root 5. And then I have to rationalize, yeah? So I would have,
-3 radical 5 over 5.
right. And yours will look a little bit better because you have more space. Any other questions about those?
Okay, so the -2 comes from the negative y-axis.
Yes.
And the negative radical 5 comes from the negative.
Exactly. So the location, whether you're in whichever quadrant you're in, you want to think about what the x values and the y values are in that quadrant, because that will tell you what side length you're going to use, whether you're using a positive or negative value, to talk about the trig functions. Mm-hmm.
Good.
All right.